Hi, Bella. How are you doing today? That might help. Probably not. Makes you look bright. I got these lights from Amazon. These are like wall lights, like wall hotel lights. And you're supposed to hang them out on the wall, but we all know how much I like hanging things on the wall from the pegboard incident. So I just keep it like near my desk. I can turn it off if I need extra light. I have one in the back actually. That's why like there's like a weird light shining from down there. Helps me see a bit. Anyways, that's the explanation for that. Today is battery vending machine part 2 / epilogue / I don't want to do this project anymore, but I have to because still have to make this thing. So although the entire arc and chamber system is completed, I still have a lot of work to do in regards to actually making this thing a viable means of transport. So today I'm focusing on making 3 things. One being the motor holder, 2 being the FPV camera that Huskaby suggested yesterday, and 3 is the attachment mechanism to the drone. So theoretically, if I wanted to attach this thing to a drone, I'm going to have to add something on the sides here, possibly like on each of the sides and on the top, just so we can lift this into a drone and have it attached there. But yeah, without further ado, let's get started. So the first thing is I'm going to turn this thing into an RC car, basically, with Ackerman steering, which is a 2-wheel drive. It's actually going to be like a T-shaped drive, if that makes any sense. There's going to be 2 wheels here, and they are going to drive the RC car. Now, they're only going to have 1 degree of freedom, unless I decide to go ahead and copy-paste this kind of mechanism on the side. I don't think I'll do that, but it's a thought. So they're going to be 2-wheel drive, which means that they probably won't go sideways, unless they want to make this some other. Maybe I do. What was that drive? Like that kind of, because there's like regular wheels where it can only have a motor attached to the side of it and the wheel spins. There's the Omni wheels, which the wheels itself have tiny little wheels on it, so it can go like front to back and then side to side. There's that third drive system. I don't know what's called though. Where there's a motor on the top and then the motor on the side and attached to the wheel, and the motor on the top turns like that. The motor on the side turns like this, and basically that's how the wheel or the robot moves. What kind of drive system is that? What are the types of drives? I know that they use it in FTC. Kind of like a real axle. Kind of. Oh, I don't know about this. If anyone in the chat knows what I'm talking about, let me know. Or I can just make this into an Omni wheel. Now, what was that? I think I have it in my YouTube like video somewhere. I saved this video, I think. Let's see. I did not save this video. I don't know what it's called. But anyways, I might make it like that. just so that it can turn in. It can be very flexible in terms of turning. Ooh, but if I do that, then these wheels are going to be unstable. It's going to be really unstable. Okay, I'll just stick with two-wheel drive for now. Decision has been made. Okay, so I need to design a way to... Did you dox yourself? How did I dox myself? What did I do? Since you're not saving this VOD. Am I not saving this VOD? Wait, what does it say not saving this VOD? Huh? What's going on? I always save my VODs. And then I can have my VODs stolen by someone on the internet. That guy still has not been banned off YouTube, by the way. I find it pretty interesting. Yeah, the VOD's saving on my end. I believe. Bellum, you can probably check that because Bellum has mod view or something. Let me get the motor. You said you was not saving this video. No, I meant the video. I meant the video on YouTube because I had a video saved or I had a video liked of like that specific drive train or drive system I was talking about, where you had like one motor on the top and one motor on the side. I just forgot the name of it. I don't know how to search it up for it. Was it called different drivetrains? I still need to wonder. What is it called? Anyways, so I'm gonna cat this motor right here. This motor, and then I'm gonna cat a wheel for it. I bought these like metal thingies. How these metal thingies work with the motor. Then I just gotta cat something for the wheel thing. Pretty much. Okay. Shouldn't be too hard. I can't see the motor. I don't know. I bought this on Amazon for $15. It was a 12-volt DC motor. Said high torque, so I guess it had gearbox. But what I was talking about, Canarsa, was the drive system in which each wheel had like a bottom-facing motor and like a side-facing motor. And then so the wheel's degree of freedom would be like 2, maybe 4. No, yeah, 2. 2 degrees of freedom for the motor. I just don't remember what that's called. Looking on this website, so no, it's not differential drive. Ackerman steering. 4-wheel drive. This is bothering me. I know what this is, but I don't know what it's called. How do you get the position of motor? You don't. Well, I mean, unless you do some nice little math with the current draw of the motor, or at least if you have some reference points, then you can align the motor with that reference point. Might be thinking of stepper or servo motors. Those are easier to get the position of because stepper motors receive that PWM signal, and the PWM signal basically decides what position it's in. And for stepper motors, you know what position it's in because each step is predefined by whatever driver you have. For motors, not really. Case is different. So unless you have some like really accurate measurement of current and really accurate algorithm to calculate exactly how long the motor was turned on, what kind of current was drawing, and what kind of torque it had, and calculate it then. Without an encoder, you don't. Yeah, basically what Canarsa said. I still don't know what it's called. Wait, Bobby, you were in FTC. What is this motor drive called when you have like 2 motors driving a wheel, one from like the top down, one from the side. I think they're firing fireworks outside. I can hear fireworks. H drive? It's called an H drive? That was called something different. No, not Windows 10 H drive. H drive robot. That's just the gunshots. No, H drive is the one I'm looking at, where you only have like it driven from one direction, I think, right? But it's like each wheel has its own motor from the side and then motor from the top. Is it really called holonomic drive? No, that's not it. That's like swerve. Yes, yes, it is swerve. Oh my goodness, yes, yes, that's the word. Thank you, Bobby. No, I want to make this a swerve drive. Yes, yes, yes. Okay, that's it. It's this thing. Where you have like one motor at the top and one motor from the side, and then it allows for it to like allows for the robot to swerve around objects. I guess that's why it's called swerve. It's really popular in FTC and Vex competitions. I should get some Vex material. You know, I wanted to get some Vex stuff for myself because I used it in the past and I love Vex stuff, but it's just so expensive. Like, it's ridiculously expensive compared to just 3D printing it yourself. You do differential swerve be cool. Let's see, differential swerve. Oh, that looks terrible. That CAD model looks terrible. I don't even know if I can fit a differential swerve gear inside. Maybe if I remove the front and then attach some thing around it, maybe that's possible. Yeah, I might just do regular swerve, where something attaches to the outside of this. There's a motor going down, and then a motor going to the side. Yeah. I want to do one, never got around it. Yeah, it's cool. I don't even think swerve would be the right choice for this kind of this kind of robot or this kind of RC car because there's not enough room. That was a good idea. Now that I know, I just gotta remember that next time I build an RC car. Anyways, this is just gonna be regular Ackerman steering. Big fat motor on the sides, hopefully wide enough so that it doesn't like hit along this thing when it turns. So one motor on each side going one direction. That's pretty much it. Okay. So I'm gonna go ahead and start counting up the motor and its components. So here's the thing. Back when I did Hyperloop, and I did that stream during the winter. I did that stream during the winter in which I made a thing. I had to test a lot of components using printing and stuff. Unfortunately, I can't anymore because my printers are being used for another thing. So I'm going to do my best to guess exactly the specifications of this motor according to what would be printed from my printer. And we're going to see exactly if this will fit within the design I am thinking of. Because if I do have a motor on each side, it's going to have to hang from the side of the battery. And it's going to have enough weight to it. So, I'll make a side plane here. It will take on the weight or the load of that battery. Oh, where did my plane go? I just deleted it again from existence. I did it again. Sketch. I'm looking for P, not V. Okay. So this motor, the largest part of this motor at least, 37 millimeters. And since I don't trust my measurements, I'm going to give this another millimeter of room, so 38 millimeters. You know, technically, like 1 millimeter of tolerance is actually enough for some of these printers. Not sure if it's... Oh, it's on aluminum, so it has to be 2.5. So if I have it 37 exactly, then 39.5 should do it. Yeah, so that's a big motor. There needs to be a even bigger wheel to compensate for that. Let's finish the sketch. And then how wide is this thing? It is 55 point something millimeters. So that means it's going to be 57. Alright, that's going to be my motor. I don't like catting parts, like the actual physical parts that I'm using for these kinds of things. But in this case, I'm just going to do it, because why not? So this is the motor. My sketch, no. Into toolbar. Oh, this is horrible. Okay. So the outer shell that's going to go around it. Actually, I should have done it in the first place instead of making the sketch. What am I doing? Okay, so 39.5, and then I'm going to go ahead and give it a little bit of a sketch outer edge of like maybe 45. Okay, so this motor holder is also going to have to connect with the upper part of this. Go ahead and move it up. Maybe like that. Right. So it has some room to roll down because the bottom has to align with the bottom wheels. So theoretically, if I have a bigger wheel, it'll take up that much space. Alright, and then I'm going to go ahead and make a rectangle, going from this end to this end, and going all the way up to like right there. Okay. And then forgot this was a file with like a billion sketches. And then you just go ahead and do this. It was 55, I believe. 57. 57. Right, you can also hide underneath as well. So I'm going to go ahead and extrude this 30 in the front and then 17 in the back. Or no. No. I'm gonna have to wheel in front of it, so like right here. Wait, no, that won't work because this will turn. So it has to be 57 in the front. Okay. Maybe. I'm going to measure this until I think it looks too big. It's too big. 40. Well, 30. 35. I'm going to do 40 in the front. And then I'm going to do 17 in the back. And I'm going to hope that it doesn't hit it. Because this thing doesn't actually turn. Let's just modify that real quick. Okay. Add a flamethrower. That's an interesting idea. Yeah, this will not hit it. Look at that. Good. Good. So even if it's horizontal, there's still a little bit of room before it crashes and dies. Alright. So, great motor holder so far. Very amateur sketch. Alright. So I'm going to go ahead and cover this hole up. Looks like there's still a little bit of room to spare. Let me just turn it to 90. Yeah, so if it's on the side, actually that's more room that I'd be comfortable with. So I'm going to go ahead and extrude that. Right, this is the back. This is the back where the wire should be. There's holes here too, but I don't think they're screw holes. Okay. So it's not going to be like that simple. So if I constrain this down to about the holes, it's about 30 millimeters. 30. Okay, and then I can extrude this 5 millimeters in. Okay, that way there's a floor, so the motor doesn't hit it. No, I should have it like this, because the motor will be inserted into this direction. So the closed face should actually be in the front. Yeah. I see a camera mount. Yes, I am making a camera mount. Sometime during the stream, or next stream. Okay, so, 2.5. I'm pretty sure these are M2 holes, M3 holes. I'm not sure if these are M3 holes. Let's check Amazon. Good, you're considering assembly. What do you mean, good, you're considering assembly, Bellum? I've always considered assembly. 200 screws later. There's too many screws for me to count. Let's see. These screws are M3s. M3 holes. Okay. M3s. Hey, the entire thing was 768 screws, right? Your battery won't last. I wonder what percentage of the weight the screws are. Honestly, I wanted this thing to be heavy, but seeing how that we have a lot of screws in now, I think my wish will be granted. Okay. So if I'm putting this thing in, if I got this correct, because the inner diameter of this circle is about 39.5. Is there a data sheet for this motor? And there is, but I don't know how to read it. 6M3 by 0.5 screws. PCD 31 millimeters. So 31 millimeters away from each other. Probably. Yeah, they are. Why don't you look at that? So they're 31 millimeters away from each other, but we all know that my printer likes to screw with me. So it's not going to let me do that. 37, that's 39.50. I'm going to give it a good, nice little estimate of approximately 32 millimeters away from the center. Chris has confirmed that he doesn't know how to read. Correct. No, 32 divided by 2 is 16. Okay. And then there are 6 of these things. So I'm going to multiply this by 6. Center point. There are 6 of these. Okay, cool. And then these are going to be my M3s. Did say M3s. And I don't think these are... No, these are pretty deep, actually. Ugh. Okay, M3 by 6 will work. I just stuck a little metal thing into the holes to test it. I pulled out some like motor goo. I think that was like lube or something. I don't know how to read, Chris. that will indeed happen. Okay, so this will just be regular holes. I'm not gonna deal with it a lot because I'll make a countersunk 5. 1, 2, 3, 4, 5, 6. Okay, these 6 holes. Let's do 2.5. I should extrude this more then. I'll put it 6 deep. 5 deep. 5 deep. It'll be 6 across. 2 down. And then 3.5. So it's 5 down that I have to change that. To -5 instead. Okay. I also have to make the thing for the center. Gear oil, probably. The center has a hole. I'm going to give it a generous serving of 13.5 millimeters. Why? If that's not correct, then, well. So, the center hole, I remember the first time I did this with Hyperloop, and I got it wrong the first try, and I wasted, like, 13 hours of my life printing one of these things. 13.5. -5. Something like this, right? Motor goes in the back, you screw it in the front, it doesn't move on the back, and then you can just wire it up to the upper side. You know what, to help with the wiring, I'm actually going to go ahead and make a sketch here. And then I'm going to go ahead and I'll first hide this thing. I'm going to make a little notch at the top here. Maybe like that, yeah. And then I'm going to extrude this inwards. And this notch is going to be where the wires go. You're going to wire it through this notch. Oh, that's going to have to go way deeper. There we go. Actually, why the heck not? All the way down. Yep. And then you put the motor in, you wire it through, wire goes up all the way into this figure. It's a win-win situation, right? And sometimes you might even need to put something more in, so I'm going to go ahead and mirror. Put this outwards, and then I'm going to extrude this all the way in. And this is 10 millimeters away. Ooh, I just realized it's not going to work. Right. Okay. New plan. This isn't going to work because A, I don't know how to screw it in. Because this is way too thick to screw in, right? So first I'm going to take this back a crap ton. Like that crap ton. And time to do some fun little additive manufacturing. So the first thing first, this needs to go forward because I designed this wheel with this position in mind, and since this position is wrong, I'm gonna have to like rethink what I do. Look over here. I think this is 10 millimeters deep. That's a weird shape. Funny CAD. Yeah, okay. There's just definitely something questionable going on here. I'm just gonna go ahead and okay, theoretically, the only junction point should be on the four corners. So the entire middle does not matter. Technically. Maybe. Hi, Michael. How's it going? Funny shape. Okay. What I'm gonna do is I'm gonna do a little bit of trolling. This circle is bothering me. I want to get rid of it. Yeah, out of here. Wait, what? It's still there? Wait, what did I delete? What the heck did I delete? No. Was this? It was that. Okay, good. Anyways, as I was saying, I'm gonna find the middle of this square. And I'm going to make another square. Why is there another center point above this? 50. That was not the center. Um, what is this? $48 point. You know what? Okay, that's fine. I'm just gonna make a thing that's about... My headphones just ran out of battery. I think we discovered new geometry. Maybe. We discovered some questionable geometry. Okay, chill. My headphones are yelling at me because they don't have any battery, and they don't like not having battery. So from this point on, I'm no longer able to hear the music, but you can. So, or I can't hear any notifications either. What am I doing? I don't know what I'm doing. I'm gonna have to sacrifice a screw on the bottom. My poor screws. But I don't think anyone will notice. So I'm gonna use this portion of space, and I'm gonna go ahead and just extrude this outwards. No. Yeah, so this stuff is to hold on, I forgot a section of space. Forgot this down here and this down here. Wait, does this work? Nah. It doesn't. Wait, no, it does? Alternative 1. No. There's an easier way. It's called... No, that wasn't the right button. I wanted to extrude it to the object so that it doesn't look this weird, because I genuinely do not know what I was thinking when I was doing this. I can't hear music. Just waiting for our classes to start this week. Oh, great. How now? Hear the music now? Anyways, what am I thinking? Oh, I can just extrude this part back, I think. There we go. Alright, so now you have easy access to the wiring, hopefully. After I do a little bit of this. Alright, so the idea is that when you wire this up, you're going to screw in the holes on all 6 corners or whatever on this side. That's going to be the only thing holding the motor together. and then everything, all the wiring stuff will be inside. So the thickness of this, I'm thinking of a 3x20 for a screw. This thing is exactly 20. Amazing. Okay, so that just means I need to like push this back by 5. Right. Okay. And so the physics of this is really weird. It's gonna this thing is gonna be held together by this piece, and then I'm also gonna have to have a different piece holding it as well, which I'm gonna make right now. Now, if you're an engineer, you know that triangles are strong. If you're not an engineer, you should probably also know that. Triangles are strong things, and I'm going to use it to my advantage by making a triangle that will solve all my problems. Take that. And then I'm going to make another triangle here and offset at 1, 2.5 there, 2.5 there. I'm totally winging this, by the way. I have no idea what I'm doing. Okay, finish sketch. Extrude this, this, this to the right. This maybe? I think that was a little bit too wide. Try 5. Please delete when modifying one of those constraints. Music is low. Really? How's that? Five. Created no geometry. What in the heck? Okay, you know what? I'll deal with this later. Anyways, triangles. So, I'm going to put triangles there, but I'm going to put the screws there first. So, should be more than enough room for some screws on each of the corners. 6.571 millimeters. Wow, that was much less than I was expecting, really. I forgot how small this thing actually was. But it should be enough. Like, the diameter of the outer screw figure is 6 millimeters. Okay. May have to modify that one sketch a little bit. It's 30 by 30. Let's give it a little bit more room. So I'm gonna have a really long screw connecting this together. 9.071 is fine. And then put the battery chamber back. Okay, that's flush. Screws, 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 screws. So 3x20s for this one. Very long screws. But I'm going to put it through the entire plastic block just to give it more of a... just increase its sturdiness. The circle looks off-centered while it's inside this view, but I do not care. Okay, I care a little bit. It looks kind of off. But it's okay. That might intersect, actually. That will intersect. Oh, this is a dilemma. So I need some kind of screw or some kind of holding place. Or I can just put it in the middle. That'll be easier. Yeah, I'll put it in the middle. Decent volume. Okay. How you can Darsa. Alright, now let's put a point. Here. Let's put another point here. A third point here. A fourth point here. A fifth point here. I don't think that will hit it, but we'll see. Okay. Seven. And I think those screws will hold together. So these are 20s, so M3 by 20s. I gotta get my M3 settings ready. So 5, 6, this is gonna be 20. Actually, was it 15? It was 15, not 20. I lied. Okay, so this figure is going to go away while I mirror the exact same sketch onto the center face. Okay, so then I'm just going to drill a hole straight through this figure, but this time it's going to be into it, and also because it's 15, which is 13, for it to be a M3 by 20, it's gonna have to go 13 plus 7. It's gonna go 7 deep, which I don't think it can go 7 deep. Yeah, it's not going 7 deep. M3 by 18. Let's have it that. So if it's M3 by 18, then it's going to go 13 deep and then 5 millimeters deep. Okay. Okay. Makes sense. 5 millimeters. 5 millimeters works. It's going to be a asymmetric M. A 3 millimeter. Right hand modeled. And an error. Compute failed. Thank you. And it also didn't save my settings. Double thank you. I don't think it likes this hole very much. This was going to be 5. And then asymmetric M is going to be 3.0. Right hand modeled. Okay, I liked that. And I don't think this is the... Whoever constrained this was an idiot. I have to redo this. Okay. Sketch. Hole. Double hole. Haha. Okay. Cool. Now, because this is going to be a symmetrical figure, plane 26 was the center one, right? No, it wasn't. I'll make a new center plane. I'm going to mirror this across the front and back, basically littering this entire figure with screws. Features. Mirror plane. Okay, good. It did it. First try. Each of these battery chambers is going to have even more screws now. I'm going to try to get over 1,000 by the end of this. 1,000 screws. Body 4 is going to be motor holder. Alright, so now that we have that, I'm going to find a way to include some sort of... Do you guys think that'll be able to hold it in place? Why are we setting stretch goals for the number of screws? This way my calculator isn't gonna hold up. Each one of these motor holders has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 more screws. Times 2, which is 26. For 8 of these motor holders, it's gonna be 26 times 8, which is 204, I think. I think it's actually over 1,000 now. Is it? That'll be fun. But anyways, is this gonna actually hold up? I'm not sure. I put like a wide chamfer on this. Not that. So like that. And that equal distance, distance and angle. The angle is gonna be like 15 degrees. No, that was the incorrect. 95 degrees. 85 degrees. That's too much. 75 degrees. Maybe even more. 85 degrees. Okay. That looks fine. 3.05. Okay. You think that'll hold up? You're 30 off. Yeah, you're at 976. Maybe if I just add like a back cover to this, you know? Like on the back. It'll make it. No, there's gonna be definitely more screws for the wheels too. Just hold your horses. Just hold your horses. More screws are incoming. I think this is gonna be able to hold it. There's gonna be a lot of force. Maybe like at this junction, maybe it'll break. I'm gonna CAD something anyways, just in case, because who knows? Maybe it'll actually break, and I'll be sad. Let me project this piece. Onto the side there. Maybe like make a point. The center. Get a line from the center to this area. Ooh, projecting that there is wacky. There we go. Ah. Right. So the center point of this is going to be right here. And connect that with the back. And then I'm going to offset this by 2.5 millimeters down and 2.5 millimeters up. Is that the same angle? No, it's not. It's 135, right? 2.5. Ah, I see what the issue is. Okay. I guess that's fine. Screw it. I'm gonna take the risk. I'm gonna say that it's probably fine. This plastic is probably gonna hold up through a lot of weight. No, it's not, because the wheel's gonna be over there. I'm gonna still need something to, like, hold this together. Oh, this is a disaster. Because if I have a wheel on this side, here, theoretical. I put this figure into action. It's connected to a wheel. This wheel is like this big. So the wheel is this big. That's a big wheel. It's a really big wheel. Okay. So let's say the motor is turning a wheel that's this big. I'm gonna be friendly with it and give it, like, all the dimensions. Come on. And then I'm gonna extrude this outwards by, like, 20 millimeters. If you saw this wheel attached to this kind of battery driving around, would you be scared? Okay, so the forces are all going to be exerted on the center wheel, right? And the back two wheels. So these driver wheels, there's not going to be much force on it because they're to the side. They're only going to be driving. These are driver wheels, right? So this kind of, this is actually fine now that I see it like this. Right, because almost all of the weight in this car is in the back. So all the weight is, like, pressed onto these, like, wheels here. So as long as these wheels are okay at carrying weight, which I highly doubt they are, by the way, the axle is plastic. The wheels are plastic. The thing holding them together is metal, but plastic. Wait, did I count the... I did not count the bottom screws. Well, oh no. Okay. Development. I didn't count these screws. The battery chamber wheels, and there's 3 of them. There's 24 of them, by the way. Each of the chamber wheels has 10 of these, right? There's 5 on one side, there's 4 on the other, 9 of these. So there's 9 of these, plus this one, the sneaky little one holding the cap together, plus 1, plus there's 4 of them holding the system to the battery chamber, so plus 4. Which means to our running total, we gotta add 14 times 24. The fire department is currently sending people preemptively. So there's 24 times 14 more screws now in each design, because I completely forgot about the side ones. I completely forgot about these ones too. The solenoid has times 8 times 2, so times 16, has 4. This is why I need a, we've beat 1,000. Alright, can we get to 2,000? So we're currently at 1312 screws. As you can probably see, I have no regard for cost. Infinite budget. Let's go. We're at $131.20 of screws. Alright, anyways. Assuming this is fine. I did everything correctly, which I highly doubt. How am I going to print this? Real question. How am I going to print this? That was an excellent question. Okay, let me make this pretty by adding fillets, because adding fillets makes an object pretty. Doop. Then to the outside, or to these two sides first. And then to this thing. Okay. And then to the outside. Okay. It's not too bad. Now, a big fillet on this side. What if I just did this? That's a weird looking circle. Actually, yeah, it's a weird looking circle. Huh. That don't look right. I'll just fillet a normal amount, like 5 millimeters. And then fillet this side. Yeah, I think I'm gonna print it on the back with a bunch of supports on this side, at least. To make things slightly easier on my part. Wow, it suddenly looks so much prettier. This is not gonna work, by the way. It's gonna hate me for this. It's not gonna hate me for this. Okay. I'll take it. Alright. Now for the final part, you gotta make sure that you assert dominance on your sketches by putting a logo. Watch me proceed to dox myself right now. Alright, where is the logo? Where'd it go? What? Oh, it's there. Oh, it is there. Alright. Applying logo. Right about. I realize that I don't have like a center point frame for this. I'm just gonna guess. I'm guessing that it needs to be a little bit more left. First of all, it needs to be bigger, but it needs to be a little bit more to the left. Wait, is that a little bit more to the left? Can't tell. Yeah, a little bit more to the left. Down could help too. Yeah, that definitely down could help. Is that centered? I guess it's centered. Oh, hey Slack, how's it going? 1312 before was 16 plus 4. I think the total is 1376 now, unless I misheard that there were another 16 plus 4 screws after the 14 times 24. Yeah, there are another 16 times 4 screws after the 14 times 24. That is correct. Alright. Dominance asserted. We have the logo. Anyways, alright, so theoretically, motor will fit. I can wire stuff. Let's color it gold or color it black. It's black because it's attached to the main body, right? Black. Yeah, style. Okie doke. Just make everything more visible again. Alright. Now, there's going to be another one of these on the other side, but I'm going to go ahead and make the motor first. The way these are connected is you have this big piece, you have the small piece going onto the big piece, like this, and then this goes into the 3D print. There's 6 screws here, so whatever that is, cool. This is going to be the big wheel that the motor is going to drive, and I think I want the big wheel to be big wheel. Yeah, all the way is distributed in the correct location, so it's not going to matter if I attach it at the end, which is exactly what I'm going to do. So just hide everything first. Okay. All right. So, I need to make a circle, which is in the correct dimensions of whatever this thing is. Which is about 25. Of 26. Okay, now I gotta look up what the dimensions of this thing is. Which is my metal mounting hub thingy. Is there a data sheet? No, there's no data sheet. Of course. I'm gonna guess that they're M3s again. I think they're actually M2.5s. That doesn't matter. I'm still gonna just use 3. I think they're M2.5s, the mounting holes. Are they M2.5s? Test this out. M2.5. It is an M2.5. Cool. Great. The distance between each of those points is... I'm gonna say 18? I'm gonna say 18.5. Away from each other. Which means from the center, it's going to be 9.25. Great. Okay, and now we have our holes. These are going to be M2.5s. So I think I'm going to use M2.5 by 8s, which means that this thickness is 5, so I'm going to have to do it 4 in. Which, I mean, 5 in works too. But these are going to be M2.5s. Which are smaller holes. I'll just do 5, why not? Okay. So, now we make the cool little design on the wheels. Because who doesn't love designer wheels? So the center is going to be here. I'm going to put 26 on the clock again. The outer ring is going to be 67. I'm going to put it down to 60. Just give it a border. And now we can play with stuff in the middle. Do things like make polygons. Oh, that'll be fun. I've never made like a polygon design before. Let's do that. So maybe maybe something like what kind of shape would be good? Triangle? What do I circular pattern this? That's cool. More. Oh yeah, there we go. Now it looks like a design. Yeah. Do I want some more stuff on here? See how this looks. So if I just go ahead and extrude this all the way through. And last time I designed a wheel, I said I did it for like purposes of aeronautics. So ours isn't really that high. Okay, so there's open that SketchUp back again. I'm going to extrude this middle piece down a little. Yeah, maybe like that. Giving it like an outer ring. Let me just mirror that over. All right. That's pretty good. And then to complete this thing, I'm just gonna fillet these corners a bit. Yeah, I mean, it's not one of the most complex designs I've ever made. That's gonna be a pain to print. I should have left the other side flat. Yeah. Okay. I feel like it's missing something. It's missing... I don't know what's missing though. if I did something like this? Well, that. It's not even. I don't like it. That's gonna look real weird. Let's see what happens when I switch the pad. Is it even in the center? It's not even on both sides, I don't think. How's that for design? I don't know. It looks weird. Okay. I guess I'll just go with that until I get a better idea. Alright, let's see what it looks like with everything visible, and then I'll cut it off for today. And then the motor holder. I think the motor holder looks fine. Triangles. Yes, triangles. So the wheel attaches to the motor like this on both sides, and pretty much it's allowed to drive if you turn the motor on, which is controlled by whatever's going on inside this box. We're going to find a way to stuff a Arduino Micro and a NRF24L01 chip inside there. And if that happens, then RC car driving battery with Ackerman steering will be complete. And then I can start printing some of these parts out to see if this actually works. Yeah, and if it doesn't fit inside, I can always tape a breadboard to the top of this thing. Right? Okay, I think that's it for today. I'm not going to go any further than that. We'll continue tomorrow and stuff. So, let's go to Kenshi now, because Kadarsa loves Kenshi. And Kenshi's the only one streaming. So, thank you so much for watching my project today, which is part of the bigger one of the battery arc. Kadarsa, were you here yesterday when I talked about this? I don't think you were. This is the battery arc. Gun control is doing shooty gun game. I see. Are you going to? I had to watch the VOD. Ah. At least you're updated to what I'm doing then. It's okay. Battery holder. Anyways, the raid timer is gonna run out on me, so let me do my outro. Thank you guys so much for watching today. It's been real fun streaming to you guys. Hope you guys have a great rest of your night, and I will see you tomorrow. I think that's it. Did I miss anything? When you did the big reveal? But thank you so much for coming. I'll see you later. Bye, guys. No problem. There's no problem. I still have to give Bellum and the rest of their kits. Oh wait! Before I leave, before we go to, hold on. I know I'm gonna get cuffed here, but like, they're finally here. Look at this. You guys probably can't see it. I finally got the stickers for Blinky Learner. Yes, I finally got them. So the kits are on their way. But bye, guys.
Just for. Oh, okay, there it is. It was late. Chris, thank you for the raid. I appreciate it. What's up, Chris? Bellum, how we doing?